So this is part B from our related rates problem that we did earlier. If you have not watched part A, I would go suggest you do so. This will help a whole lot. But if you haven't, no worries. We will cover this problem, part B, completely separately, and we will be able to solve this entire problem without the need of problem A. So, consider the triangle formed by the side of the house, the ladder, and the ground. Find the rate at which the area of the triangle is changing when the base of the ladder is 7 feet from the wall. So, given from part A, which we also found from this main information, that we had a triangle here that has x squared plus y squared equals 25 squared. And the base of the ladder is being pulled at 2 feet per second. So that's dx dt equals 2 feet per second in this direction. Now, in part B, consider the triangle formed on the side of the house, the ladder, and the ground. Find the rate at which the area of the triangle, so we have dA, which is the area, as it changes with respect to time, right? So it says find the rate at which the area of the triangle is changing. So we want to find how the area is changing when the base of the ladder is 7 feet from the wall. So we have x equals 7. If we're going to consider the base as x, it's asking us when this equals 7, what's the rate of change for the area. So we don't have enough information here to find area. So we have to think of more stuff. Well, could we find the y? Well, we sure could. If we plugged in our 7 here for x squared plus y squared equals 25, we get y equals 24. This is a 7, 24, 25 triangle. Now, what is the area of a triangle? If you remember, it's A equals 1/2 base times height. Well, we can call x the base, and we can call y the height. So this will be 1/2 x y. That's our area equation. So this is everything that is given to us. So let's start solving from there. So if we have a is equal to xy over 2, we want to implicitly derive that. So we get a is, or not a, but rather dA dt. So we took the derivative is equal to, and we're going to have to use product rule here. So we get derivative of the first times the second. So we get dx dt times the second, which is y. That's all over 2. Plus derivative of the second, which is dy dt, times the first, which is x, all over 2 as well. So we can actually find the solution from here, correct? Well, let's try that out. Let's start plugging in what we have. We have dA over dt is equal to dx dt, which is 2, times y, which we said is 24, over 2. And we have plus dy dt. Now, the reason I asked if to watch part A is that given from part A, we found that dy dt was equal to negative 7 over 12 feet per second. This is why this information is crucial. I'd suggest go watching that part first. So we have negative 7 over 12 times our x, which is 7, all over 2. And this gives us an answer of 527 over 24. So this, and for area, that's basically feet squared per second. So the area this is describing is this area right here. So when x equals 7 and y equals 24, the area is changing at 527 over 24 feet per second. And if you notice, this is a positive number, which means that the area is actually increasing as x is being pulled away. So that is how you do part B.